Good day everyone and welcome once again to my YouTube channel. Today we are going to be looking at chemistry, and the aspect of chemistry that we are going to be considering will be on chemical reactions. Now we have quite a number of reactions in the world of chemistry, and majority of them happens to be chemical reactions. Though we still have another group of reactions in the world of chemistry that are considered as nuclear reactions. Those ones are the reactions that are involved with the protons and the neutrons of an atom to actually give you different substances. So that is known as nuclear reactions, and that's under nuclear chemistry. But looking at chemical reactions, we have quite a number of reactions. Written on the board, we have the combination all through to redox. But mind you, this lesson will be split into two videos. Now, this is the first video. In the second video, we are going to be considering the redox reaction. Okay? Mind you, when we talk about chemical reactions, in one of my previous videos, I explained about the chemical changes and the physical changes. When we talk about chemical changes, we are referring to changes in which new substances are formed and they are not easily reversible. But in the case of physical changes, no new substances are formed and they are easily reversible. Now, coming back to this, being that we are considering chemical reactions, looking at the combination reaction, when we talk about combination reaction, the word combination is coming from the word combine. And to combine means you have two or more substances that you are bringing together to form a single. So now, in the case of combination reaction, we have two or more substances coming together to form a single substance. Okay? Mind you, when we talk about chemical reactions, we are making references to two stuffs. And what are these two stuffs? You must know reactants and you must know products. Okay? Reactants and products. Now, in the world of chemistry, reactants are usually written before the arrow of a reaction, while products are usually written immediately after the arrow. For example, if I have A plus B to give C plus D, in this case, the reactants are the ones that are written before the arrow, and then they happen to be A and B, while the products are the ones written after the arrow, and then they happen to be what? C and D. Okay, so the products are the ones written immediately after the arrow, while the reactants are the ones written before the arrow. Okay, so looking at combination reaction, you have two or more reactants combining to form a single product. That's all about combination reaction. For example, let's say I have A plus B to give me AB. In this case, we have two reactants combining to form a single product. That is combination. For example, let's say we have another example, ABC, to give us ABC. That's A plus B plus C to give ABC. That's still combination reaction. And interestingly, this combination reaction could be element-element combination to form a single substance, or compound-compound combination to form a single substance. For example, let's say we have this reaction, iron plus sulfur to give iron sulfide. In this case, this is an element, iron. This is also another element, sulfur, and it ends up giving us iron sulfide. So in this case, you could say that this is an element-element combination to form a single substance, and that is a typical example of combination reaction. Then we could have compound-compound combination, for example, PbO2 plus SO2. In this case, both of them happens to be what? Compounds. This is a compound and this is another compound. And then it ends up giving us PbSO4. So this is a compound and this is a gas, and then of course it's still a compound too, and then it ends up giving us lead tetrahydrosulfate of a 6 compound. So in this case, this is compound-compound combination to give us what? To give us a single substance. So it means that when you have element-element combination to form a single substance, or you have compound-compound combination to form a single substance, so long you have more than one reactant to form a single substance, then it falls under combination reaction. Then the next is displacement. Now, displacement reaction is a kind of reaction that involves an element and a compound, usually. Okay? an element and a compound usually. And what does that mean? It means that it will be having, let's say, A plus BX, and then it ends up giving us AX plus B. What have you noticed in this reaction? You will notice that A was able to pick up X and then form AX in product, while you are left with what? B alone. So it means that A was able to displace or remove B and pick up X that was initially attached to B to form AX, while B is left alone. And mind you, the reason why A is able to displace B to pick up X is because A is higher in the activity series or the electrochemical series than B. When we talk about activity series or electrochemical series, we are simply referring to a series in which you have the extent of electropositivity and the extent of electronegativity in terms of differences amongst elements. That will be treated in our subsequent lessons, okay? But mind you, this is higher in the activity or electrochemical series than B. So it's able to remove this and then ends up picking X to form AX, and then B is left alone. Let's see a typical example of this kind of reaction. For example, Zn plus CuSO4. In this case, you have a product ZnSO4 plus Cu. What do you observe? Now, Zn is able to remove Cu and pick up what was initially attached to Cu, SO4, which is, and then it becomes what? ZnSO4, while Cu is left alone. This reaction is similar to this, in that the Zn is represented with A in this case, the Cu is represented with B in this case, the SO4 is represented with X in this case. So Zn is able to combine with SO4, which is AX in this case, and then you have ZnSO4, while Cu is left alone. So this is known as displacement reaction. And what was the key thing about displacement reaction? Now, the element in question that is able to displace another one in a compound must be higher in the activity series or the electrochemical series for it to be able to what? To displace the other. Okay, so that is for displacement reaction. Then the next reaction is decomposition reaction. When we talk about decomposition reaction, we are simply referring to a reaction in which, upon the application of heat, mostly the application of heat, upon the application of heat, it will cause the chemical decomposition or splitting or separation of a compound into its component elements in order to form its diverse substances. For example, let's say we have A, B, C, and then you apply heat. Most times, decomposition reaction is usually facilitated upon the application of heat, and then it ends up giving you A, B, and C. So this is an example of a decomposition reaction. What do you observe? Now, there was the application of heat on this reaction to cause the splitting of these substances, and then it ended up giving us A plus B plus C. Now, I can give you an illustration. For example, let's say we have KClO3. Now, of course, this is actually potassium triiosochlorate 5. And then when you apply heat on this compound, it ends up giving you KCl plus O2. Balancing the reaction, you have 2 here, and then 2 here, and then 3 here. Of course, the reaction is balanced because now, how many potassium are you having? 2 potassium, 2 chlorine, and 2 times 3 in oxygen being 6, and then 3 times 2 is also what? 6. Okay, so this is an example of a decomposition reaction. But more specifically, you can call this a thermal decomposition reaction, in that it involves the application of what? Heat. Okay, all right. Then looking at the next, dissociation reaction. When we talk about dissociation reaction, we are simply referring to a reaction that is related to decomposition. But what distinguishes decomposition reaction from dissociation in terms of thermal, meaning the application of heat, is that for dissociation reaction, it is a reversible reaction. And what does that mean? A reaction that proceeds in two directions, meaning in this case you have just a single arrow representing this reaction, and then it means it's only proceeding in one direction. But when you have a reaction in which it proceeds in two directions, for example, A plus B plus C in this case right now, and then it ends up giving you A plus B plus C. Now what do you notice? This reaction is reversible in that you have the forward and the backward reaction. So hence you would say that if it is applied to this to facilitate the decomposition of this into A plus B plus C, it means you can call this a thermal dissociation reaction. Why? Because the reaction is reversible. If assuming the reaction was just only proceeding in one direction, what would you have said? You would have said that the reaction is a thermal decomposition reaction in that it's only proceeding in one direction. So what's that the discrepancy between thermal decomposition and thermal dissociation? One is reversible, and which is that? That is actually what? The thermal dissociation, while the other being thermal decomposition is irreversible. Okay? So that's that about that. I can give you an illustration. For example, remember this compound, ammonium chloride. Now, when you heat this ammonium chloride, it gives you NH3, which is ammonia gas, plus HCl, hydrogen chloride gas. But mind you, when you cool these two gases, you end up getting this one. So this, you can see, the forward reaction here is thermal. Is it decomposition or dissociation? Of course, it's what? Dissociation. Why? Because it can proceed in two directions, meaning the reaction is what? Reversible. Okay, don't forget that. Okay. Then the next is catalytic reaction. Now, when we talk about catalytic reaction, we are simply referring to reactions that proceed in the presence of catalysts. Reactions that proceed in the presence of catalysts. And mind you, a catalyst is any agent that alters the rate of chemical reaction. Alters the rate of chemical reactions. Okay, that's a catalyst. And mind you, when we talk about altering of the rate of chemical reaction by a catalyst, the altering here simply means that a catalyst can increase the rate of chemical reaction, or it can reduce or decrease the rate of chemical reaction. Okay? But one thing you need to know about catalysts is that they are agents that tend to alter the rate of chemical reactions, and usually at the end of the reaction they remain chemically and quantitatively unchanged. Okay? But though their physical structures can be affected, but in terms of their chemical nature and their composition, they remain unchanged. In terms of their mass also remain unchanged. Okay? Mind you, those reactions that are accelerated or retarded, reactions that are accelerated or retarded by catalysts are known as catalysis, meaning that there is actually catalyst present that could accelerate the reaction or could retard the reaction. Okay? And mind you, a catalyst could be referred to as a positive catalyst or a negative catalyst. Okay? Now, a positive catalyst is a catalyst that tends to increase reaction rates. Okay? While a negative catalyst is a catalyst that tends to reduce reaction rate. Again, a catalyst does not have the ability to start up a reaction, but rather it has effect on already proceeding or progressing reaction. Take cognizance of that. It's very, very important. Okay? We could be having reactions like the combination catalytic reaction. So reactions that are influenced by the presence or absence of catalysts are called catalytic reactions. And mind you, we have a combination catalytic reaction. We could also have decomposition catalytic reaction. We have quite a number of catalytic reactions. Okay. Now again, there are some agents that can affect the catalyst present in a reaction. Of course, such agents are divided into two parts. We have those agents that are called promoters, and then we have those agents that are called inhibitors. Now, what are promoters? Promoters are simply agents of a catalyst that tend to increase the reaction rate and assist the catalyst to carry out that reaction. Okay? Then while inhibitors, they tend to slow down reaction rates of an enzyme, of a catalyst rather. Okay? Now, mind you, do you know that catalysts could be divided into two parts? We have inorganic catalysts. And then we have organic catalysts. Okay? Inorganic catalysts and organic catalysts. Now, organic catalysts are simply catalysts that are referred to as enzymes. They carry out reactions in a biological system. Then while inorganic catalysts are catalysts that are actually involved in chemical reactions. And mind you, we have two divisions of these inorganic catalysts. Initially, I've told you that there are catalysts that are called positive catalysts. And we have positive catalysts and we have negative catalysts. Okay? Positive catalysts and negative catalysts. So it therefore implies that it is only the inorganic catalysts that can further be broken down into positive and negative. And remember, I told you that positive catalysts are catalysts that tend to what? To increase reaction rates, while negative catalysts, they tend to what? Slow down reaction rates. Okay? So that's about catalytic reaction. Then in the case of double decomposition reaction, when we talk about double decomposition reaction, we are simply referring to a reaction in which there is usually the exchange of ionic radicals between two soluble compounds in water that would end up giving you a soluble substance as a product and another insoluble substance. Let me explain. Let's say I have AB as a substance plus CD as another substance, and then at the end I have A reacting with D to form AD and B reacting with C to form BC. What do you notice here? Upon the application of heat, this is similar to decomposition, but it's just that these two substances that are involved in double decomposition reaction, they are usually soluble substances. And when they exchange their ionic radicals in the obedience to electromagnetism or electrostatics, in that when this one splits, can end up giving you A plus rather, and B minus, while this one gives you we have C plus and D minus. What do you notice? Now A plus and D minus attracted each other to form AD, unlike charges attracting to form this, while B minus and C plus attracted each other to form BC. Okay, that's ionic exchange of their radicals. Okay, and then it ends up giving you AD and BC. Now remember, I said that the two substances involved, they must be soluble substances, and then it ends up giving you what? They end up giving you a soluble substance and an insoluble substance, meaning these two are soluble. You can assume this one to be soluble, and while this one is insoluble. Now I can explain using an illustration of silver nitrate, and then we have sodium. We could have sodium chloride. Now silver nitrate happens to be a soluble compound, while sodium chloride is also another soluble compound. Then when you react both of them by exchanging of the ionic radicals, you know this one splits to give you what? A plus, Ag plus, and then NO3 minus, while this one ends up giving you what? Na plus and Cl minus. So this one will be attracted to the negatively charged ion here, and it ends up giving you what? AgCl, while this one reacts with this to form NaNO3. So what do you notice? This one happens to be a soluble salt or a soluble compound, while this one is what? Insoluble. So this is a classical example of double decomposition reaction. Okay, so that's all about double decomposition. Okay, but mind you, in our next video we'll be looking at redox reaction, and we'll consider quite a number of things about redox reaction. So the thing is, it's my hope that you've been able to understand what I've just explained concerning diverse reactions from combination all through to double decomposition. So the thing is, just try as much as possible to review the video over and over again for you to understand it better. Okay, so don't forget to subscribe to this YouTube channel, like, comment, and share the videos for your friends out there so that they can be notified or aware of these videos, these educationally rich videos that can be of help to them. Okay, so I thank you for watching this video and stay tuned to this channel. God bless.